Nice sweater.
Thanks, I got it at Macy's.
Oh.
Where's your Christmas sweater?
Oh, well, it's a non-denominational festivities.
Oh yeah, that's right.
Bob Ross's secret video.
Oh, what you got there, Zach?
I don't know. It's some secret video. Okay, let's go look.
Have you heard of Bob Ross?
Just rumors.
Yeah, I know.
Names scattered here and there.
Should we
I'll see
open
what
it
it
up?
is. Yeah, see what it is.
Inside?
Whoa. I heard my grandma used to talk about these. They said you would put it into like some sort of machine to watch it.
I haven't seen one of
Oh
those in a
my.
long time.
Should we pop it in? I've
Yeah,
got one
let's
of
pop
those.
it in. Let's pop it in.
I've got Soldier Boy's new console. Maybe that'll run it. Here, I'm gonna. You can pop
Yeah,
it in.
I got
I'm gonna turn on the TV here. Here, just wait. Let's let the TV run. Oh yeah. Sorry about that. If you hear some noise, it's just the new COD game. You're so dumb. You gotta open it up.
Oh, you're right.
Yeah, there you go.
Yeah, let's see what happens here.
Yeah.
Oh, is that the new COD?
Yeah, I got it a couple days ago.
Nice.
Yeah, let's see.
Welcome to my physics video with me, Bob Ross. Today we're going to be learning 10 happy physics facts. Our first happy physics fact is that a scalar only has magnitude, while a vector has magnitude and direction. See that right there? That "and" is the most important part. Our next big idea is that the derivative of position with respect to time is velocity, while the second derivative of position, or the derivative of velocity, is acceleration. Now isn't that beautiful? Acceleration is the second derivative of displacement with respect to time. Now we have three little equations that are very important and make up kinematics land. I'll paint them now. Here's our three new equations. Aren't they just lovely? And always remember, the vectors here get lonely, so we gotta add a little friend on top so that they have a little friend in their kinematics land. Our next physics idea is that you have to add vector components tip to tail, and then notice how we took the component vectors here and made one resultant. Another beautiful part of this is that everything has its place in the coordinate system. My old friend Isaac Newton once told me 3 laws that he had come up with that explain forces. Here they are now. Look at these. They're so nice. They're in gold. It's because they're so important. My personal favorite is number 3. For every action, there's an equal and opposite reaction. Watch this here. Notice how when I hit my paints here, they go up. That's because it's an equal and opposite reaction from my hitting it. Now, we have all this stuff here, and things are getting a little tricky. So what we're going to do, we're going to go to our 5 steps for success, our best friend in the physics world. Our 5 steps for success, here we go. Now look at this here. We got all these nice steps. Now you see this French word here. That's solver. In American, it's solve. Make sure to drink your coffee before you get into this one, because you're going to need some energy. Energy is forces, just like over here, times a distance. And the first thing you're going to want to know about energy is energy final equals energy initial, unless there's some work. Beautiful. Look at that. EI equals EF. That must mean there was no work done on the system. Speaking of work, that's what's up next. Here we go. Work is basically the same as energy. It's a force applied over a distance to an object. The equation is right here. Isn't this beautiful? But notice, one thing's a little strange. Up to now, most of the things we've had are vectors, but work is a scalar. Oh! I just collided. You know what's in collisions? Momentum. Here's the equation now. Look at that. Isn't that wonderful? Here we have another vector, our good friend. And now look, Pi equals Pf in a closed system, even if the collision is inelastic. Remember that collision I had earlier? That was scary. But, good thing the time took a long time. Now, a change in momentum is an outside force acting on an object for a certain amount of time. It's called impulse. Remember our friend Newton from earlier? Well, he came up with a nifty thing called calculus. And it's just beautiful. Look at this little symbol here. That's an integral. That means sum. See here? We have a graph. That's the force in newtons. And this is time in seconds. When we have a graph of force with respect to time, we can take the integral, or the area under the curve. And that's how we get impulse. But don't get tripped up if you see on the AP test a J. That's also impulse. Just remember, sometimes your friend Jim changes your momentum. We call him Jim Pulse. Look at all this beautiful physics here. Isn't it wonderful? Thank you for joining me on this wonderful physics journey. See you next time.
Wow, dang, that was life changing. I mean, Zach, Zach, get up. Zach, were you asleep for the whole thing? You missed all he said about forces and energy and gravity and all. It was. I'm gonna ace the AP test now.
The only thing I learned is that gravity's a myth. I mean, the world's flat, and so how does that work? There's no gravity.
Oh! Oh!
Now that's gravity.
Actually, I forced myself to do that.
Well, Bob Ross, I'm so thankful that you were here to help me with physics. I'm gonna ace the AP test.
Oh, you bet you are. And I'll always be with you.
Blip.
Does Kim want more children?
Blip.
Do you want more children?
Blip.
What are we gonna do today? What are we gonna do today?
We're gonna shoot that light out.
Oh, Hood Bob Ross, you don't care. Oh, Hood Bob Ross, no! Oh!
They call me the Blowster.
Oh my gosh!
Doesn't mean that they don't like each other. So remember, tip to tail.
Gang stuff.
All right, hellbillies. We got white trash.
Hang on, this me.
We got white trash. We got white trash. Bob Ross here.
That's right.
All
Martha,
right.
where the cornbread? Why no one emptied the toilet out of my trailer? Gosh dang it. This is the third time this week.
All right.
I can't take this no more.
Ross,
It's
Eddie.
third Bob Ross. Yep, go for it. Put her in.
Now pull up a little bit. Go.
Okay, go.
Whoa.
Gang stuff.